In order to work with threads, we have the following classes and interfaces. We have the thread group class, and the runnable interface. All these reside in the Lang package. Threads have their own properties. Every thread have property. The properties of a thread is, every thread has a name, it has a priority, and it belongs to a group. So, there are methods in the thread class which allow you to work with these properties, called get or set name, get or set priority, and get thread group. Till now you have not written any threaded program. You just wrote a plain application. You did not multi-thread your programs. Whatever program that you wrote was the main thread or the system thread. That was the heavyweight thread part. So, even that thread has the name, priority, and the group to which it belongs. The name given to a main thread or the system thread is main, the group to which it belongs is main, and the priority is a normal priority which is given to it, that's 5. When you create a thread, you can specify the thread with its name at the time of creation. And you also specify the group to which it belongs at the time of creation of a thread. If you do not specify the name for a thread when you create a thread object, the API, the thread class, assigns the thread with the name as thread 0, thread 1, thread 2, so on and so forth. You can of course change the name of a thread by calling a setName method later on. Now for the group. The thread group has to be specified when you create an instance of a thread itself. As you notice, there is no set thread group, there is only a thread group. So you create a thread group object and specify that object of thread group when you are creating a thread object. If in case you do not specify a thread group to which a thread should belong to, then automatically the thread will get placed into the same group as its parent thread. So in the main thread, it belongs to the thread group called main, and in that main thread, if you were to create a child thread and you don't specify the group to which the child thread should belong to, it also belongs to a group called main. So if you wanted to be grouped separately, create a thread group object and pass the thread group object as parameter when creating a thread object to its constructor. Why do I need to create thread group or group together threads? For example, if I want to manipulate set of threads together, that's when thread group is useful. Let's say you want to put n number of threads with all the threads within a particular group to a sleep state, you can put it to a sleep state. So you can manage the set of threads at once using a thread group. That's the reason for having thread groups. Certain functionalities can be provided commonly when you group these threads together, instead of calling them on each and every thread. The priority of a thread can be specified between 1 and 10. 1 being the minimum priority, 10 being the maximum priority. So therefore, normal priority is 5. You can set a priority for a thread, of course, by calling a set priority method. You need to specify a value between 1 and 10. If you specify a value beyond this range, either way, you get an exception, illegal argument exception. If suppose I don't set a priority for a thread which I create, then the thread gets the priority same as its parent thread. Apart from all these properties, what else can I do with a thread? Suppose you want to have one thread waiting for another thread to complete and then continue with its action. Then you call a join on the thread. Let's say I have thread 1 which has executed certain step of information. So we have thread 1 and thread 2. Thread 1 has executed some amount of its execution or functionality, after which it would need to wait till thread 2 completes and then it should continue. Then what you need to do is, in thread 1 you ask thread 1 to wait till thread 2 completes. So you say thread 2 dot join inside of thread 1. So this goes into a join state wherein thread 1 waits till thread 2 completes. Once thread 2 dies, then thread 1 continues with its further execution. This join method throws interrupted exception. Similarly, even the sleep throws interrupted exception. Now, when does this interrupted exception occur? Whether it's for join or sleep, is that suppose, for example, whatever the thread 1 has to do after this particular join point depends on only whatever the thread 2 had to execute up till here, after which thread 1 need not wait for thread 2 to complete, assume. In that case, in thread 2 what we can do is, we know after this particular statement thread 1 can proceed with its functionality, but we have called join because join means to say once thread 2 dies then continue. So what we do here in thread 2 is called thread 1 dot interrupt. So interrupt is a method in the thread class as well. When we call an interrupt method on a thread which has called join or which has called sleep, it throws the interrupted exception and comes out of the join or the sleep state and continues further in its execution. So now thread 1 can continue as well as thread 2 can continue with its action. That's the requirement for join and interrupt methods.